Moving on to example 2. We've got Tanner standing on the 30-meter line of a metric football field, which is measured 0 to 100 meters, and kicks a football at an angle of 53 degrees with an initial velocity of 25 meters per second. Alright, so the very first thing we need to do is draw this out. Because all of those words, they can be kind of confusing. But if you draw it out, hopefully you'll be able to pick up something. So let's see what we've got. Standing on the 30-meter line, so that's going to be the 30-meter line right here. And then the ball is kicked at an angle, so it's going to do one of these things where it goes up and then comes down, right? And this is parabolic, and we're launching from ground to ground. So that should trigger a couple of things in your head by now. But we've got 53-degree angle here. That's a 3. 53-degree angle, and the initial velocity is 25 meters per second. Alright, so 25 meters per second in this direction. It's at an angle, so we already know we've got to resolve that vector into its components, right? It's got to have an x component and a y component, and they have to be behaving separately. Alright, but first, the question is asking for the time the football is in the air. So if we need time, then we can go to the kinematic equations. We can start picking them, but the very first thing that you should be doing is writing down your given information. So we have g is going to be about 10 meters per second. We know if we use the starting velocity, we can stop it right here, right? We can stop it at the top because something magical happens right there. Our velocity in the y dimension is 0. So let's go ahead and do that. We'll stop it at the top. So we'll say our final velocity in the y equals 0 meters per second. And we know that if we're stopping it at the top, then whatever time we get is really only half of the total time. So maybe we'll need the total time for something else. So it's kind of just a reminder in our brain. If we cut the parabola in half, we're only dealing with half of the information. Now, let's see, we have v as a function of time. So that would be vfy equals v0y minus gt. gt, we've got that. We just need the initial velocity in the y. I already told you how to get that. We're going to do the magnitude, trig, angle. And when you do that, you get 20 meters per second. So plugging all of this in and rearranging for t, you should get, use this as a check, t equals 2 seconds. And that's only your half time. So the total time equals 4 seconds. Time the football is in the air, 4 seconds. Is that reasonable? If you watch football, you're talking about a 4-second hang time for a punt. That is absolutely reasonable. 4-second hang time for even a kickoff. Absolutely reasonable. All right, so now where are we on the football field? That's going to be our final position, right? That's what we're looking for. We have all of this y information. We now know the time is 4 seconds. That's useful. If we're looking for our final position, we can use the displacement equation, which is x equals x naught plus v naught xt plus 1/2 at squared. What's our acceleration in the x direction? 0. So there's our equation. Our final position equals the initial position, which was the 30-meter mark, plus initial velocity in the x times t, which is 4 seconds. The initial velocity in the x can be found by resolving this 25 meter per second vector into its components. And we're going to do that the same way. Magnitude, cosine, because we're on the x, 53. And that equals 15. Little side note here. A bonus. If you're dealing with a situation where y is exactly down and x is exactly horizontal, you can use a little trick to remember, am I supposed to use cosine or sine? If you write cosine like this, and then sine like this, cosine on the x and sine on the y. Cosine. Maybe that helps, maybe it doesn't. Alright, so plugging in this, 15 times 4 is 60 plus 30. We're going to end up on the 90 meter mark. The trick to that question, of course, is adding in that 30 meters. A lot of students probably wouldn't remember to do that. The highest height the football reaches, that's the highest height. Can we use this equation again? Let's see. YF equals Y naught plus V naught Y T minus 1/2 GT squared. Yes. Let's see. The initial height is 0. We can do this. Absolutely. We've got all of this information. So let's go ahead and figure it out. Move all of this. I might erase something. Let's see. The initial velocity in the y direction we found over here to be, whoops, right there, to be 20. And the time, what time are we going to be using? If we're finding the maximum height, that happens right here. So we're going to use only half of the time. So we'll use the 2. Minus 1/2 of 10 times the t squared, so 2 squared. Going throughout all of that, we've got 40 minus 5 times 4, which is 20. So our final height should be 20 meters. Cool. Next. All right, next we have to graph it. Show it graphically. Horizontal distance. Remember, there is no acceleration here, so this is going to be a straight line. So there's no curve. We're starting at the 30 meter mark, and it goes for 4 seconds. So there should be nothing in between 4 and 5 seconds. And we go all the way to the 90 meter mark in the horizontal direction. Our horizontal velocity, we calculated to be 15, and that is constant. No acceleration, right? There is no air resistance in this situation. For the vertical height, we started off at 0 and we ended at 0 4 seconds later, and we reached a maximum height of 20 halfway in between. Is there acceleration in the y direction? Yes, there's gravity. So that means it's going to be curved, and we're going to curve it on up, and then we're going to curve it on down. And then the vertical velocity. We started off with an initial velocity in the y as 20 at t equals 0. At 2 seconds, we changed direction, right? The parabola is going up.